Now in circles, the one on the handout we did was x squared plus y squared equals 25. It's a good example here. Yeah, we've got a circle, and two things you need on a circle. You need the center, which in this case, the center is 0, 0. We'll talk about shifting them next time, but the center here is 0, 0. And the other thing you need on a circle is the radius. What radius does this have? R. The radius is the distance from the center out to the circle. What radius does this have? It's 5, okay? So this is the radius. One way you can take it, from here to the center to the circle. But you measure it anywhere, it's the same all the way around. That's the good thing about the circle. All right. Now, of course, it's not shifted at all. We'll talk about that, like I said, a little more next time. But you see how that 5 comes in from this equation here? Isn't that 5 related very much to that 25?
Square root.
It's the square root of 25. Or another way to put it, this number right here is r squared. It's the radius squared. It's another way to put it. And so that's how they typically, for these circles that are centered at 0, 0, they typically write it in general, x squared plus y squared equals r squared. That's a circle. Center is 0, 0. Radius r. R squared, so square root that, you got your radius. So those are really, really nice, easy ones to do because, say I have x squared plus y squared equals 9. Obviously, it's in the format of a circle. The center is 0, 0.
Radius is 3.
Radius is 3. Square root of 9. Take this, yeah, that's not the radius, it's the square of the radius, so you got to square root it to get the radius. And so that gives us a very easy way to graph this because, like we said, on a circle, all points are 3 units away, the radius away from the center. So here's my center. So I'm just going to go out 3 units in all directions, which the 4 easiest directions would be north, south, east, and west, if you will, right? Right, left, up, or down. So go out 3 from the center here, 3 from the center here, 3 from the center here, 3 from the center here. And if my scale was a little more square, yeah, you get your circle. That's where grid paper comes in handy, but you get the idea. The only real tricky business maybe, what about this one? X squared plus y squared equals 21. What is that? Circle, 0, 0, center. What's the radius?
Square root of 21.
Square root of 21, yeah. Yeah, they won't all not be nice squares there on the end. Could be, you know, square root of 21, which is about, if you plug that in, what? 4.58. And so the graph here, 1, 2, 3, 4, 5.8. 1, 2, 3, 4, 5. So 4.58. 1, 2, 3, 4, 5. So negative 4.58. Connect them up in a circular manner. And if your grid is squared off, it looks more like a circle than that one does, but you get the idea. Okay? All right, now, here's the deal on an ellipse. What they typically do, I think this is pretty standard method. Here's what you want for an ellipse. X squared over a squared plus y squared over b squared equals 1. So we want that, I mentioned this previously, you want that one side to be 1. If it's not 1, you want to make it be 1 by dividing. Okay? We'll do one maybe. But the a squared and the b squared, typically on the ellipse, they want the a squared to be bigger than the b squared, the a bigger than b. They don't do that on the hyperbolas, even though it kind of looks, but for the ellipse, and it's because of the focus equation, basically, I guess. But anyway, if the a is greater than b, so this one's bigger than this one, here's what you've got. You've got one of these that's ellipses that are longer than it is wide. Now the way we're going to graph this ellipse is it turns out this one's a, and this one's b, and this one's negative a, and this one's negative b. The intercepts there, the x and the y intercepts. And yeah, a is that square root of the a squared here, and b is that square root of what's under the y squared. That's basically how we're going to do it. Yeah, like I said, the reason they do the a is greater than b thing is because the focus, it's a different equation. It's c squared. C is going to be the distance to the focus from the center. C squared equals a squared minus b squared. So you can see why we want a greater than b, because if we don't do that, then that gives us a no solution equation. Yeah. And so if we solve that, square root it, that gives me the c distance to my focus. Focus 1 and focus 2. So anyway, it's not that bad. All right. Now, what can happen is, okay, so we've got a greater than b. So it very well could be that the x squared one, that thing underneath it, is less than the thing underneath the y squared one. So in that case, the b squared would be under the x squared. I mean, you don't really have to think about it that much, but if we've got a is greater than b, then the y squared one's bigger, then that's the a squared. And so you're going to have, the a is bigger, so this is a, this is minus a, and this is b, and this is minus b. The b is smaller, and so you get this taller than wider ellipse, you see. I mean, like I said, you don't really have to think about it that much other than for your focus, you want to subtract the larger one minus the smaller one. But anyway, that's the basic format we want for an ellipse. All right, so x squared, number 1, over 9 plus y squared over 4 equals 1. Graphing these things is not that bad if you can follow what we're doing here. So how far in the x do I want to go?
4. 3.
Square root of 9, yeah. So in the x direction, I want to go out 3 both ways. 1, 2, 3. And then 1, 2, 3, back. How far do I want to go out in the y?
2 and 2.
2 and 2. 2 and minus 2, right? Square root of 4. So in the y, since that's what's underneath, is 4. I square root it's 2. And it, it works out. You don't, well, is that going to be longer than it is wider, wider than it is longer? The numbers work out. The vertices, like I said, those are the endpoints of the major axis, the longer axis. And so this is my vertex, and this is my vertex, since that's the longer axis. This is a shorter than it is there. So that's what? Plus or minus 3, 0, the vertices. What about the foci? Just plural of, should have said foci here because it's 2. What's c squared equals a squared minus b squared?
Square root of 5.
9 minus 4, yeah. So yeah, on the c² equation, you don't square root those, you use the actual numbers, 9 minus 4. So c² equals 5. So c would be plus or minus the square root of 5, which I believe that's, what? .23, 2.2. And so you're going to go out along the major axis, 2.2, backwards and forwards, from the center. So you go 1, 2, 0.2, 3, 0.2, yeah. And then back here. So there's my foci. Not that bad. So that would be what? Plus or minus square root of 5, 0, or if you round it off, I'm okay with that. What else? X squared over 25 plus y squared over 36 equals 1. Ellipse, right?
Yep.
It's not shifted, so the center is 0, 0. Let's graph it to get the other bits of information here. How far on the x do I go? 5. So 1, 2, 3, 4, 5. Back. 1, 2, 3, 4, 5. Forward. And the y, square root of 36, so we go out 6. 1, 2, 3, 4, 5, 6. And then down 6. Yeah, so this one's, the major axis is, it's taller than it is wide, so get the ellipse that's longer this way than it is wide. All right, so vertices wise, where are the vertices now? Are these the vertices?
-6.
No, these are the vertices, right? It's the major axis endpoints. So it's 0 plus or minus 6. Yes. What are the foci? Well, c squared equals a squared minus b squared for the foci. And so that's c squared equals 36 minus 25, and that's, just the bigger one's the a squared, but you just don't want a negative number there. So c would be the square root of 11 plus or minus, which is about 3.2. So where are those? Again, it's along the major axis, so it's up and down here. So 1, 2, 3 here, 0.3, and then 1, 2, 3, 0.3. So there's my foci. So that's 0, comma, that's square root of 11, plus or minus. Yes? One more ellipse, and we'll work on the hyperbolas just a little bit. All right, so number 3. 9x squared plus y squared equals 36. A couple of things. What shape is that? Why is it not a circle? Yeah, you got a 9 here. If you had a 9 here, we might be thinking circle. Yeah, it's not a circle because of the 9. Yes, that's a good way to put it. So what is it? Well, it's x squared plus y squared, so that's the ellipse. If it's x squared minus y squared, it's a hyperbola, right? We talked about that. But it's not in the right form, is it? What's the proper form for an ellipse to graph it, our proper form? I need to have a 1 here. So divide through by 36, yes. Divide everything by 36. And so that cancels. That'll be a 4 on top, 1 on top, 4 on the bottom. So the x squared over 4. Nothing cancels here, so it's just y squared over 36. But then that side's 1 like we want. Now, We got this whipped. We can do the, whatever we want. X direction, we go out plus or minus 2, square root of that. Y direction, we go out 6, and then we can do all of our other good stuff. Vertices, foci, whatever you want. I can get you there. All right? Okay.